Hello and welcome back to the Building HVAC Science Podcast. It's our goal here at the Building HVAC Science Podcast to help create better, more knowledgeable HVAC and building performance technicians by helping the two professions better understand each other with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. So today we're going to have a conversation with Enrico Bonilauri, and he is a building consultant. His business is called Emu Passive, and they're closing the gap between mainstream construction practices and advanced proven building science. This sounds like fun, at least it does to me. So let's just get into this interview where Eric and I get a chance to speak with Enrico Bonilauri about a study that he's done. And there's a link to the study, his business, and his LinkedIn profile in the show notes. So buckle up, listen in, and then take a look at the study after you've heard the episode.
Hello, everyone, and welcome back to another episode of the Building HVAC Science Podcast. I am Eric Kaiser, and virtually today with me, Bill Spohn. And today we have a very special guest, and I hope I'm not going to butcher your last name too badly. Enrico Bonilauri, I believe, is the correct pronunciation.
That's perfect. Thank you so much, Eric, and thank you both for having me here today.
Oh, thank you for being here.
This is great. Enrico, I got a chance to listen to one of your presentations for the Green Home Institute, and you were talking about a study you had recently collected. Just pre-interview here, you spoke about how you finished it during nap time.
Yes.
How do you do that when you're napping? Was it you napping?
Yeah, it was not me. We had a baby about a year ago, and so I took a few months of paternity leave. And during those nap times of our daughter, I was able to finish up a study that actually took us 2.5 years of this research to be put together.
Let's jump back a little bit and get a little bit of background on who Enrico is and what led you to the point where you did this interesting study.
I'm Enrico Bonilauri. I'm a registered architect back home in Italy, and that is where we started Emu as a company 15 years ago in 2009. It was Emu Architetti, so we used to be an architecture practice. And over the years, we discovered passive house as a building standard. We adopted that as our benchmark. And we started providing training to builders we were working with because it was very hard to do any high-performance building with builders that had no experience prior of that. And when we moved the company to the US in 2017, we started teaching American builders about passive house and about high performance. And in doing that, there was a big gap in the comparison between the international passive house standard, the American passive house standard, and just the regular building code. We selected 50 projects from the consulting side of our company, and we used those 50 projects from different climate zones, different conditions and whatnot, to then compare those building standards to one another using different metrics. And it took us 2.5 years to get there. But really, we wanted to answer, we developed our own curriculum for the training. And so one of the questions we wanted to answer was, how does passive house compare to Energy Star or Pretty Good House or Energy Code? So we used those 50 projects to answer the question.
Wow. I've never heard of anything like this before. Does anything like this exist? Is this the first time?
I think there were smaller studies done looking at energy performance, but this is something that Fuse did back when they split off from PHI maybe 10 years ago. And I don't think they ever did a comparison with Energy Star or the Zero Energy Ready Home. And I believe at the time, Pretty Good House did not exist as a concept. So we tried to answer the questions from our builders with this study.
What type of methods did you use? You said there were 50 different projects across multiple climate zones?
Correct. So,
how many different standards were there? Could you enumerate them? Or
if I'm not wrong, there were 12 different building standards with 50 projects, and we used projects that came through our doors through the consulting side of Emu. So we had the passive house energy model executed already in PHPP. And so we tweaked those energy models to meet the different building standards. But we selected the 50 projects to be representative of different climate zones. These are all single-family home new construction projects. That is a pool of projects that we had many projects for. We wanted to have kind of a statistical approach to this comparison.
What would you say is the biggest takeaway? And we can get into a little bit more detail, but the biggest takeaway from this study, this work?
That's a great question. I think how difficult it is to compare building standards apples to apples. Even just a lot of the time we spent was in trying to have a fair comparison between the American standard, the international passive standard, Energy Star, the different IECC building code standards, and then how to compare different metrics to one another, like energy performance, indoor quality, durability. I made up a scoring system that is as valid as any made up scoring system, because one cannot really compare kilowatt hours of energy saved versus the expected durability of a building versus the expected indoor quality inside the building. So I literally made up a 0 to 100 scoring system to try to compare that, but that was difficult and hard to do.
So is the unit of measure a Bonilauri?
Yes. I am definitely going to use that, and it's not going to come out well.
So this was agnostic to construction techniques and modes of construction?
Correct. This stems out of a round of modeling that we do in projects, typically at the schematic design of a project, what we call the project boost. And we do that at the schematic design out of try to help teams to make informed decisions as far as what kind of window package they need, what kind of insulation package they need, what kind of heating and cooling load they're going to have, what kind of pressure ventilation system, what kind of filtration, all of that stuff. And we do that by having basically a neutral approach towards assemblies. We basically have some incremental R value modeling that does account for some thermal bridging, but it is pretty equivalent or independent from the actual type of assembly that one chooses. So if that makes sense.
Is this study available? Do you share this?
The report is available for free download, and I can send you the link.
Was it the link you sent before?
I think so.
Okay, the Dropbox.
Yep.
I will put that into the show notes for anyone who's curious to dig into more details there.
Yeah, and there is a specific appendix that is for the state of California, which is slightly different, but there's basically 2 big PDF files that you can download.
Yeah, and they can find that right on your website too, correct?
That is correct, yes.
And that's emupassive, emupassive.com. And then there's a section there for reports and everything too.
What's been the reaction?
A lot of good reactions, a lot of surprises. One of the biggest outcomes was how little improvement the 2024 IECC provides in terms of energy efficiency compared to the 2021. It's actually 1% worse in average over the 50 projects that we evaluated. That was a big shocker. Then there was other surprises foremost, where we took the 50 projects and we analyzed in average where the biggest heat losses occur. And we did that for both a code-built building and a passive house. This is, again, averages over 50 different projects in different climate zones. And a lot of the builders that we teach, they believe that most of heat losses occur through air leakage, because on social media, there is a lot of the conversations about air sealing and air barriers and all of that. And we found that the air leakage is about the 4th greatest heat losses or cause of heat losses. And it is second to heat losses that occur through the ground to the outside air. So that is something that was a surprise to many, that we found the heat losses through the ground to the outside air to matter so much. And the biggest one was heat losses through the windows are about 1/3 of the total heat losses, but I don't think anyone was surprised about that.
When you're looking at that, I guess I'm curious, and maybe this is in the weeds a little bit, what kind of methods did you use to measure those heat losses in real time?
Again, this is modeling based on PHP, the passive house energy software. And PHP uses a pretty detailed building standard to calculate heat losses through the ground. That is standard ISO 13370. And that is just the state of the art of how we calculate heat losses to the ground. On YouTube, we have a few videos where we literally show some case studies of thermal bridge modeling. One of them was that we published maybe a month ago, was for a retrofit in Montana, where the builder and the architect had planned for double stud walls and triple pane windows and all of that good stuff. But because it was a retrofit, they were not planning on having any insulation at the slab. And what our analysis showed was that because I did all of that good stuff for the walls and for the air sealing and all of that, maybe 60% of the total heat losses was heat losses through the slab to the outside air. And so that was a pretty compelling analysis. And they ended up adding insulation on top of the existing slab to overcome that.
Is there a certain depth into the ground that becomes less of a problem, or is that pretty much a universal all the way down? Like, see if you have something 8 or 10 feet in the ground.
That standard basically accounts for up to 60 feet down into the ground. And at the end of the day, the ground insulates as much as concrete. And so really, if you think of your house or your building sitting on a block of concrete, it's easy to understand how heat can go into the concrete and then get lost to the outside air. This is really a part that goes down into the ground and back up to the outside air.
Gotcha. So it's basically conducting essentially your slab and up the walls to the outside air.
Correct. And it is pretty fascinating how that occurs. And Ian, you have been doing this kind of analysis for the past 15 years. So it's duh.
That's a universal word, even from an Italian. Right?
Yeah, of course it is like that. But it is, if you've never seen that, if you never considered that, then it may come as a surprise.
Yeah, because I think a lot of times when we think of that, we think of it conducting straight through the wall, not vertically through a wall from low up high like that. I got to say, I had not thought of that in that method before.
And it is, heat goes in all directions. It can go up, down, left, right, inward, outward. It goes in all directions because it follows the path of least resistance. And that is something that code really fails at addressing. So that is something that I feel pretty passionate and excited about when we develop construction details for projects and seeing how stacking materials in different ways can literally interject heat flows that occur in our walls.
Wow. You're talking about stacking things in walls. I'm assuming you're talking about like frame walls, above grade walls, or?
All the things. We geek out about all assemblies and all details. This is a very convoluted way to then the outcome has to be finding something that has to be simple to do on site. And that is something that, in my opinion, simplicity is never overrated when it comes to building. Try to keep it simple, try to make it so that if you can utilize off-the-shelf products, I'm a big fan of that because the least people have to learn from scratch, the more familiar they are with products and processes, the more successful we can be in actually executing these details.
Did this simplicity of execution enter into the study in any way?
No, this study was intended to compare different building standards.
And these are existing, yes, got it.
Yeah.
But if a method is available that has simplicity, it's maybe worth more Bonilauri points?
Possibly. That is, I see a lot of construction details floating around on social media, and I'm amazed about how much we try to mitigate the thermal bridging caused by timber studs, for example, which, having done 15 years of rainbows and thermal bridge analysis, they're like little mice. And the big elephants in the room are steel, concrete, any metal really, and masonry. So when it comes to details, I see a lot of effort put towards insulating a wood stud, but then there's a big copper sheet of flashing cutting straight through the insulation. And a 24 gauge sheet of copper can allow more heat to escape than 3 or 4 studs combined. That is something that we are improving our narrative to try to provide better and more relatable examples. But there are some big elephants in construction details today that are not really addressed. We're trying to improve the way we communicate that.
Part of what you do then is actually training as well as the consulting. You do a lot of training and teaching actual builders, and I'm assuming designers, how to do this well, yeah?
That is correct. Actually, 2/3 of what EMU does is passive house training. And we have a training that we call passive design build training, because we're really trying to bring designers and builders together in the same room. And we literally pair them up in teams so that they work together and they get to know each other. I took my own passive house training about 15 years ago. I am still today in touch with some friends that have taken the training with me back in the day, and we still please one another, but also learn from each other and from each other's project, and we become each other's network. So something that we teach in our boot camp training workshops is for participants to get to know one another so that you can compare projects, you can compare your experience with different products. And that is actually most of what EMU does, training.
So when you're talking about training, how many of the people coming through your training are actually doing passive house when they walk out of there? Are they doing it 100% of the time? Are they doing it 10% of the time? And can people that come through your training, could they apply that maybe to buildings and houses that maybe aren't passive house that we could make a little bit better incrementally?
That's a great question. I think so. About half of the people that take our training are builders. About a quarter are architects and designers, and the remaining quarter is a mix of tradespeople, developers, homeowners, policymakers, fun bunch. It is not so. The science that we teach is the science of passive house. They can be applied to any project, whether you're pursuing certification or not. And that is very important. In fact, only 1 out of 5 projects we work on as consultants actually pursue certification. The other 4 out of 5, they want to use the passive house science to be better for the indoor quality, resilience, and efficiency, but they don't necessarily care about being certified. And people that come to our training, typically the first project they start implementing the knowledge. It may not be a certified project, but they learn how to identify issues like, hey, there's a big steel beam going through my building envelope, or actually this flashing detail, we do not want to have this sheet of metal coming through my insulation because that's a thermal. Like, they start to implement that right away. It may take some time until they get the first project that is pursuing certification, but at least they're implementing the science right off the bat in any of their projects.
You're giving people EMU vision.
EMU visions and Bonilauri points.
There you go, together. Wow. And then another thing, this isn't a new kind of coffee, but what's an EMU pod?
The EMU pod is a, 7-foot tall, 4-foot wide, small home that is a fully enclosed, tiny little passive house envelope that we have designed and that we use in the training with built-in exercises for people to air seal, to insulate, to install an actual triple pane window. So it is our 3-dimensional textbook that we have designed for people to learn about passive house, but to learn about passive house in an actual physical environment. There's too much training that is only PowerPoint based, and that is not how people on site actually think. So we developed that specifically for people to understand how things come together.
You're based in Colorado, so is the EMU pod only in Colorado?
Now we actually take it on the road. Right now, I'm in New York City. We are having a boot camp week, that is the week of training with the pods, in Brooklyn. And we take that to about 10 different locations every year across the country.
Wow.
And that link to that's on your website. We can include that in the show notes for the training.
Yes, there is a page where we list all of the upcoming boot camps. We have Fort Collins, Colorado coming up, Missoula, Montana. We're going to be in California twice in the fall this year. So we have a few things planned out.
So all your training then is portable and remote. You don't have like a training center that people can go to out in Colorado?
Correct. At our office space in Colorado, we have a conference room, but that is a conference room where we do our training about a couple of times a year. We do not have a facility. We found that we want to use the training as a way to help build local communities. So whenever we do a week of training, there's also always a social event to try to bring the people together, people that have taken the training in the past, people that are interested in building science in general, people that are curious about passive house or the training. Sometimes there's tours, like tonight we have a tour. In June in Colorado, we have the Passive House Open Day. So it's a way to try to promote a building science-based community locally.
How often do these fill up? I'm assuming that you get quite a few people interested in them. Do they fill up fast if people want to get registered?
It depends on the location. Repeating locations, they fill up fast. And sometimes we are in locations where there are local incentives to cover the cost of the training, and those, of course, fill up faster. So it depends on the landscape we are in.
Very cool. And I think this is something I'm really excited to see going on. I had no idea this was even happening because, let's face it, we can all use more knowledge. And I think it's really cool that you're taking this knowledge to people rather than having people have to travel somewhere really far away just to go learn about something.
Yeah, it's already hard enough to take a full week off. In fact, we also offer the course part of the week online. So one could take the first 2 days online and come in just for the hands-on part. We're trying to make it flexible so that it's already a big ask on someone's schedule. So we started offering the online with COVID, but now we're pretty flexible and someone can decide to go online and take the course on their own. We have live Q&A so that we try to also connect and have a little bit of an online community. But then when they decide to come in for the hands-on, at least it's only 2 days instead of a full week.
So how many people do you take into a hands-on class?
It is up to 24.
Wow.
Yeah, it's pretty cool.
That's a pretty cool class.
Yeah, it's manageable. You can meet people. By the end of it, people get to know each other. So I hope they stay in touch. That's something I learned a lot. I learned as much, or probably more, from people that I've connected to than from the training itself.
Yeah, sometimes the community is often the best teacher because you can learn from what other people are doing or maybe what they're seeing and then apply it to yourself or your own projects rather than 25 people having to make the same mistake. One can do the thing and 24 more can learn.
Yeah, and it becomes a work opportunity for many. In fact, many people that come take our training are people that are getting back into the construction industry and they're getting started as builders, and they have no prior knowledge about what things are supposed to be like. So they want to start using the passive house science as their benchmark. That's pretty cool.
Skip ahead to the next chapter. When it comes to this conundrum with everyone thought air leakage is number one, but it's really thermal through the foundation, especially slab, I guess. Especially slab, is that correct?
Slab or conditioned crawl space.
So for air leakage, there's a device called a blower door you can test and you can assess that. How can you assess this slab leakage in an existing construction, say?
That's a good question. It's really having a good survey of what your building is and then having a model done to see how your building exchanges with the ground. And it is something it really varies. Larger buildings protect the ground from the exterior environment better, so the ground underneath is more protected in a way. So it's a pairing win-win situation, as opposed to smaller buildings are smaller, so they protect the smaller. It's three-dimensional in a way.
I think a lot of this is what you're describing. You talked about the heat flow being three-dimensional.
Yep, exactly.
Yeah, I've heard that from more than one source in high-performance building, that heat flows are three-dimensional, and we too often think of them as two-dimensional. And we forget about that third dimension.
Yeah.
I recall seeing some thermal image videos of windows you did a while ago.
Yes. So something that we do, I have an infrared camera with me at all times, pretty much. So, which is not necessarily cool, but I like it. But in trying to compare, this is a way to try, if you have people understanding and see, you cannot unsee. So in the workshop, we have the pods that are these tiny little houses that are designed and built according to the Passivhaus standard. They have continuous insulation, very good air seal, triple pane windows, and all the good stuff. And each team of the participants builds and assembles their own. Now, we also have a pod that is built to the 2021 energy code that is just something that travels with us, and we use that as the baseline. And at the end of the workshop, in fact, that is what they're doing right now upstairs. At the end of the workshop, we heat up the pods for a while, and then we look at them with an infrared camera. And the most mind-blowing picture is when we compare side to side a Passivhaus window to a code minimum window, brand new window, but double pane, double hung, not very good performance. When you compare that to a Passivhaus window, the comparison is amazing, because if you look at that with an infrared camera, the Passivhaus window you can barely see because it is so insulated that it holds the heat. So at the infrared camera that measures the heat, you cannot not really see that. It blends into the background, as opposed to the code window, which glows. It's so bright with heat losses. It is night and day difference. And that is something that people that take our course see, because it's proof of concept pretty much.
We've talked a lot about heating. What about space conditioning, cooling? Is the problem not as big, easier to tackle, or?
Cooling, in a way, is more tricky, and it's a fair point. And in fact, about a quarter of the buildings that we included in the study were selected from cooling-dominated climates. So about 13 projects were in California, Texas, and Florida. Another quarter was in very cold climates, Minnesota, mountains of Colorado, Montana. And then half were in kind of middle-of-the-road climate zone 4 and 5, Chicago, Denver, New York. Cooling is definitely interesting because you have different dynamics. Something that came up from the study, and I will be presenting at a conference in Austin, Texas in a couple of weeks, is that oftentimes in warm and hot climates, we do not insulate under the slab. And because in doing that, that is a good strategy, because you're using the ground as the heat sink. So what was detrimental for heat-dominated climates that we just talked about is actually an asset in hot climates. What I found in the study, and it was pretty interesting, and I'm expanding the research on that right now, is that whether or not we want to have insulation on the slab actually depends on the temperature we want to run the space at. So if you want to run the space at 75 degrees, then it's convenient to have no insulation on the slab. But instead, I'm talking like cooling set point. Instead, if you want to run the temperature at 70 degrees, cooling temperature, it may be convenient to have insulation on the slab because we may have gains through the ground up the slab. One of my buddies, a person that I mentioned, took the Passivhaus training with me 15 years ago. He is the mechanical engineer that designed the Passivhaus office building in Dubai. So they had pretty hot. We can agree that it's pretty hot. And they completed their Passivhaus certified project in 2015. So 10 years almost. And in the analysis, they were seeing heat gains from the ground. Also granted that the locals wanted to have the set point temperature to be at 68 degrees. Super, like 120 degrees outside, and then you want to run your building at 68 degrees. So big delta there. Literally, they were having heat gains clearly through the windows, through the envelope, but also from the ground up.
With that much hot ground around there, I can imagine there would be a lot of gains coming through there. So realistically, it really depends on the delta between what the ground is going to be and what you're going to run the indoor at.
Correct. Is that relationship that determines if and how much you want to insulate. In other words, I think the key here is that the science of passive hours, whichever goals you may have, this science teaches us that if we want to get to goals of buildings consuming little or no energy, we can no longer rely on a prescriptive approach. Prescriptive approach is basically someone somewhere at some point in time writing down decisions to the questions that you are going to have in your project. Basically, when you have your questions pre-answered without you even speaking them out loud. Does that make sense?
Sure does. That's called rude construction right there.
Pretty much. But if we want to get to actual high performance and net zero, low carbon, all of the good stuff, we need to move away from a prescriptive approach and start to actually look at our projects through an analysis, whichever the goals.
Very good. This has been tremendously educational for me. At first, it was like that presentation you gave was tremendously educational. Now it's even, whoa, you really poured it on.
Yeah, thank you.
I want to ask real quick before we end this out. Can you just give a real quick overview of some of the topics that you would cover in your 4-day class? Should people want to go take that or have interest in that? What are some of those topics that you're going to cover, specifically with the pods and things like that in this?
Looking at how to make buildings more durable and healthy, depending on climate-specific conditions. We covered that extensively in the course, which is basically 2 days, about 15 hours of course. And then in the pod, in the hands-on part, we have 4 types of wall assemblies. 2 of them are stick frame for residential, and 2 of them are commercial types of assemblies, so CMU and steel framing. And we look at planning. So set up drawing, start to plan it out, because once you break ground, if you don't have your details figured out, you're going to lose. You're going to lose time, you're going to lose money, you're not going to meet your goals. So looking at goals, looking at details, having a plan, and then executing on those details and on their plan. We completely brand neutral. We get donations of products, but we don't get commission. There's no vendors in the course. It's a brand neutral environment for people to come and experience firsthand different products that they may have never heard of. We have sheep's wool, we have hemp bats, as well as smart vapor retarders, and that is all pretty simple stuff to use once you get your head around it. But to cut a bat of hemp, it takes some effort. So if you want to try to use it on your products and you never cut it, you may as well get some sample and try to cut it, because it's going to take a long time. So sequencing, teamwork, goals for air sealing, window install. It's a very good, intensive 2 days of the hands-on part.
Sounds like a lot of fun. You're making me want to jump into one and just go take it now.
Yeah. It is a lot of fun. And we have games too, where participants are required to do an exercise as a team, and whoever wins the game, they awarded a better performing product to install on the pod. We're building off of the competition, of the competitive spirit of our building.
Very nice.
Oh, wow.
It's a lot of fun.
This sounds like I'm ready to go jump in one right now. I don't know about everybody listening out there, but I may have my name on one of these before you know it.
Yeah.
Go look at the show notes, get your links, find out more about the study, the classes, and about the EMU systems, and Enrico especially. Thank you so much for coming on.
Thank you, Bill, and thank you, Eric, so much.
Hey, thanks for listening to this episode of the Building HVAC Science Podcast. If you're in the market for some of the tools or test instruments that we refer to in the podcast, we have a lot on the TruTechTools.com, TruTechTools.com, and you can use the offer code HVACBS for a nice discount. The Building HVAC Science Podcast is a production of TruTech Tools Limited. Full disclosure, I'm a co-owner of TruTech. The opinions voiced are those of my guests, my co-host, or myself, depending on who's speaking, of course. I also host the Res Talk podcast. That's a production of ResNet, resnet.us. You can learn more about the rapidly expanding world of home energy ratings and the peripheral topics. If you'd like to reach out, contact us at marketing@TruTechTools.com. That's TruTechTools.com. And thanks again for listening to this episode of the Building HVAC Science Podcast. Until next time.